Good day to all our dear televiewers and subscribers of DepEd Teleturuan. This is Rosemel Q. Quijada, Junior High School teacher of Camp Pino National High School, your teacher presenter for today. Let us start our discussion with this situation. A local government organization launches a recycling campaign of waste materials to schools in order to raise students' awareness of environmental production and the effects of climate change. Every kilogram of waste materials earn points that can be exchanged for school supplies and grocery items. Paper, which is the number one waste collected, earn 5 points for every kilo. This table shows the points earned by grade 9 class for every number of kilograms of waste paper collected. By looking in this table, what happens to the number of points when the number of kilograms of paper is doubled? How about if the number of kilograms of paper tripled? And how many kilograms of paper will the grade 9 class have to gather in order to raise 50 points? That's correct. As we observed, if the number of kilograms of paper is doubled, the number of points doubled. And if the number of kilograms of paper is tripled, the number of points also tripled. In short, as the number of kilograms increases, the number of points also increases. And by looking on this table, we can say that the grade 9 class have to gather 10 kilograms of paper in order to raise 50 points. This situation has something to do on our lesson for today, which is about direct variation. Direct variation is a relationship between two quantities, x and y, that can be written as y is equal to kx, where k is not equal to 0. Y is equal to kx may read as y varies directly as x, y is directly proportional to x, or y is proportional to x. In y is equal to kx, k is what we call the constant of variation that relates the two variables. Let us have this table. Let us solve for the value of y given the following values of x by using y is equal to kx. Let us use 4 as the value of k. Let us solve for the value of y if the value of x is 1. Y is equal to 4, that is the k. Multiplied by 1, the answer is 4. So the value of y is 4 if the value of x is 1 and if the constant variation is 4. Next, if the value of x is 2, we have y is equal to 4 multiplied by 2. So the answer is 8. And if the value of x is 3, we have y is equal to 4 times 3. The answer is 12. Now, by looking on the values of x and y, we will notice that when we divide the value of y to the value of x, the answer is always 4, which is our constant of variation. In direct variation, we can solve for constant of variation by dividing y to x, or we have k is equal to y over x. We can also notice that as the value of x increases, the value of y also increases. Or on the counterpart, as the value of x decreases, the value of y also decreases. And that is the relationship of two variables or quantities in direct variation. Let us have the following statements. Let us see if the given statement shows direct variation or not. The amount of money raised in a concert to the number of tickets sold. Is this direct variation or not? Correct. This statement shows direct variation because the more tickets sold, more money will be raised in a concert, or the less tickets sold, less money will be raised in a concert. How about this one? The number of persons sharing a pie to the size of the slices of the pie. Correct. This is not a direct variation because If there are more persons sharing a pie, the sizes of the slices of the pie will be lessened. In short, more person, less pie, or less person, more pie. So this is not a direct variation. Now, let us study how to translate the given statement into an equation. Let us have the following statement. Let us use K for the constant of variation. For example, A varies directly as B. When we translate it into an equation, it will become A is equal to KB. The variable that will be isolated is the one that will be read first. Number 2, M is directly proportional to N. May be translated as M is equal to Kn. And number 3, D is proportional to T may be translated as D is equal to KT. That is how to translate variation statement into an equation. Next, how to determine if the given table of values expresses direct variation or not. In order to say that the table of values expresses direct variation, we must check first the relationship of the two variables. If x increases, y must also increase, or if x decreases, y must also decrease. And the constant of variation of the given values must be the same. Let us have this table. As we can see, as the value of x increases, the value of y also increases. Now, let us check if the constant of variation of the given values are the same. Let us use k as constant of variation. We already know that to solve for k, we have k is equal to y over x, or y divided by x. So we have 4 over 2, 6 over 3, 8 over 4, and 10 over 5. When you simplify this, the answer is 2. So the constant of variation is 2. Since the quotients are equal, therefore, this is a direct variation. Next, how to determine the constant of variation in the equation of variation given the table of values. To determine the constant of variation, we will use again k is equal to y over x. In this table, when we divide y to the value of x, the answer is 2. The constant of variation in this table is 2. And to determine the equation of variation, all we have to do is to substitute the value of k in the equation y is equal to kx. So we have y is equal to 2x. The equation of variation is y is equal to 2x. Next, how to determine if the graph shows a direct variation. For us to determine if the graph shows direct variation, the graph must be straight line and it passes through the origin. This is an example of the graph shows direct variation. There you have it. We are about to have a short break. Please stay tuned for more discussions.